He was gone yesterday, so he's catching up. Some of you were like, praise the Lord, someone asked because he wanted to too.
I didn't even notice.
At least he was gone yesterday, so I didn't even know.
Yeah, how do you get those?
Oh my word! Okay, I'm teaching you how to find the page. Does that help?
Yeah, posting it on YouTube.
Wait, so you're gonna tell us how to find the YouTube channel?
How do you find my website? Okay, do y'all know how to find my website?
Yes.
Do you realize every Monday in RenWeb there's a link to both the class calendar and whatever that gets to the website? Okay. Cool. Now where? Wait, we're good? Oh, it doesn't. RenWeb?
I don't think I said.
Do you guys remember tinyurl.com/doingmath, right?
Yeah.
Okay. Yeah, I bookmark it. It's easy.
Bookmarking is way easier. It also means
I found Mr. Shank's art channel.
What? He has an art channel.
Oh yeah.
Art, no, heart.
Oh. Mr. Crawford has art channel.
Ricky, didn't we find it for this class?
Let's just comment. Did I do this?
Find it in this class.
Wait, pause! We have kids that have no clue how to work the website. And second semester. Now what?
No, Tyler, I don't know how to get to a YouTube channel.
Here you go. Tyler. Or you can go to YouTube and do Miss Dweck HCS. That's my channel. But this takes you straight to the Precalc playlist. Precalc.
I think I spelled it wrong.
Now it's going to start playing. Steve, where's the X? You're good. Woo, that was close.
Wait.
Alright, cool kids, we're coming back. Here we go, number 14.
If you play the video you're recording right now, just will blow up.
Yeah, it'll record.
So
Alright, stop. So we have plus 2 pi n, doesn't matter if it's n pi or pi n. Why are those there? Coterminals. Number 20. Did you guys get tangent alone by plus or minus square rooting first?
No.
Oh. Okay, you didn't do the homework, you're not allowed to answer. Then you have to ask yourself the question, okay, these are the ones I don't like. These are the hard ones. The multiple angle ones, you have to ask yourself the question that when is tangent this, and deal with the 3x later. So I need you guys to think PEMDAS, because a few of you probably got messed up on this. Honors didn't like it. Some kids that were in here working last night didn't like it. Don't touch the 3x. PEMDAS, look on the outside first. When is tangent plus or minus root 3? My cheater chart people, this should be easy for you. Why? If you look in the cheater chart, don't you have a tangent column?
Great.
Sorry, a tangent row? It was on accident, but thank you. Tangent, right? When is tangent? No judging. We have our 0, we have our 30, we have our 45, we have our 60, and we have our 90. My cheater chart people. Where does tangent become root 3? Hey, this is one place where the cheater chart is nice. Because in the unit circle, you don't have tangents written, right? But in the cheater chart, you do. You can say tangent is this guy at all the 60s. Wait, which 60s? I don't care. All of them. Any of them. It's in the unit circle plus or minus. That means in this quadrant. Yes, in this quadrant. Yes, in this quadrant. Yes, in that quadrant. Yes. Now, wait. These answers don't look like those. So what happened? Right? Who's this angle? Yeah, 60 degrees in radians. Pi over 3. Okay. I could have written pi over 3 plus 2 pi n, 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n. Ugh, that's 4 answers. How many answers did they write, first of all? 2, right? Because there's an or. 2. Which two angles did they choose? This guy and this guy. But they didn't add 2 pi n. Remember, mathematicians love shortcuts as long as they can. There's some creativity. They didn't add 2 pi n. What did they add? Why? Go pi away, half a circle away. Where are you? Oh, you're on the other guy. Go pi away from this guy. Where are you? Oh, you're on the other guy. So they said, forget it, we don't want to write this 4 times, that's lame. We're going to write it twice and just cut the pi in half and say, great, we can get to the other side by adding pi. Okay, then.
Could you write pi over 2n and then just only write 1?
No, and here's the reason why. Good idea though, because you're like, why not just write 1 then? Here's the problem. Are the 60s 90 apart? Pi over 2 would be 90 apart. If you added 90, 60 plus 90 is 150. It would be the wrong one. Does that make sense? So these are 60 apart, so we can't go pi over 2, but we can go half a circle to get to the other side, half a circle to get to the other side, and only have to write 2 formulas. But we're not done. Struggle. Who's equal to pi over 3 plus pi n and 2 pi over 3 plus pi n? 3x. How do I get rid of a 3? Multiply everybody by 1/3. Him, and him, and him. Hence why you have pi over 9 and pi n over 3. So some of you guys looked at the back of the book and you're like, this doesn't look like what she did. Well, these problems might have asked you to go a step further. Yeah.
But is it okay if you have 4 answers?
Yeah, 4 answers, totally fine. You could have done, once again, this guy plus 2 pi n, that guy plus 2 pi n, that guy, and that guy. You would have just had to, once again, multiply everybody by 1/3. But yeah. Technically, if you had 4 answers, all 4 angles, you're not wrong. They just wrote it faster. Alright, cool kids, let's keep going. Let's clear the ink. And let's, that's not what it is. Number 28. This guy's messy. But why? You got a cosine and you got a sine squared. What property did they use, guys? Pythagorean property. Sine squared is 1 minus cosine squared. They moved everybody to one side to get a nice little factorable expression. Then they said, sweet, set each factor equal to 0. They used their unit circle to solve. Couple more seconds to get the answers. But we walked through the process. Unit circle answers. They only asked between 0 and 2 pi. That's why the answer is only these few angles and no n. Number 36. Check it. What's the first thing they did? Property. Yeah, property. Then what did they do? Yeah, common denominators. Didn't they multiply sine by sine to get sine squared over cosine? But who didn't have an over cosine? This guy. So you put him over 1 times cosine over cosine. Common denominators. Life was good because that's just 1. That's just... They didn't even go to secant. Look at those lazy bums. They said, forget it. We like cosine. So they multiplied up and they divided and said, ha-ha, cosine. Unit circle done. Wasn't that a lot easier than that? Ugh, what do you even do with that? I don't know. This, pi over 3 and 5 pi over 3. Cosine is positive in the first quadrant and in the fourth quadrant. Couple more seconds. Number 40. He wasn't hard until you got to the 2x dude. But remember, what did I tell you? Do you start with the 2x once you get here, or do you start with the sine? Sine, start on the outside, and you ask yourself, when is sine negative root 3 over 2? What quadrants is sine negative in? Good. Quadrants 3 and quadrants 4. So that'd be 4 pi over 3 and 5 pi over 3. Booyah! Booyah! What'd they do? Is that 2x equal? Is that 2x equal? They just did the normal 2 pi n because there wasn't that weird half circle away if there weren't more answers. But you had to solve by multiplying everybody by who? Divide by 2 or multiply by 1/2. If you divide by 2 or multiply by 1/2, then it simplifies down to your final 2 answers. What were you allowed to do in number 60? No shouts for joy, no jumping up and down, no putting your hands and saying praise. What were you able to do in number 60?
Cheat.
Absolutely.
Use your calculator.
Same thing.
You're able to use your calculator. They did more math up here than you even had to. Couldn't you have, technically, once they said use your calculator? They might have said use the quadratic formula in the meetings. But you could have checked it because it was weird decimal answers anyway. You could have just graphed this side and said, hey, let's find the zeros. Which there should be 1 and 2 and 3 and 4 like we saw yesterday. Cut your window down 0 to 2 pi, remember? And find the zeros using the second trace feature. Now, do you guys also see how they showed you how it works with the unit circle? Sorry, with the quadratic formula? You have to plug in, there's A, there's B, there's C, plug and chug, you get -2 and 2/3, but tangent equals that, you grow set equal to, use your calculator with tangent inverse, bleh. Don't stress too much. This one's a decimal answer. You'd be able to graph it and find the zeros. Sound good? Okay. You guys are happy today. You usually like your calculator ones. What happened? Number 86, another calculator one. You graphed him, and said how many intersections between, I think, 0 to 2 pi? Does anybody have directions? Was it 0 to 2 pi? Okay, cool. So you're able to cut down your window and just look. There should have been 3, which means there should be 3 solutions. They didn't even make you find them. You could have found them though, so good job. Number 94, the Ferris wheelie one. Guess what? We're just going to make him extra credit. Sound good?
Yes.
If you're able to get it, awesome. If you aren't, don't.
So you don't have to do that?
Don't worry. You don't have to do that one. It's a great physics problem. And if we had more time and if we were further along in our semester, if we were further along in our book at this point of the semester, we go over him. He's a great problem. Super practical, super physicsy, but pretty calculus. We're just getting you ready for physics, right? Alright, here we go. Let's go. Section 5.3, yeah, we're going to start 5.4. That's our goal today. I didn't ask if you guys had any questions on the odds. We went over the evens in pretty good detail, I think. How many of you guys, after doing this homework, are in the midst of doing it and getting stuck? Say, I need to know my unit circle. Okay, you need to study that thing, okay? Because the ones that raised their hands, some of them are ones that they had pretty good the first time. The rest of you guys, it's been kind of hard the whole time. So you gotta know your unit circle, otherwise stuff's gonna get hard. Like 5.3. Now, before we start section 5.4, I'm gonna go ahead and put it up on the screen so you guys can kind of start seeing it. If you want to start writing, you can. What do you see in 5.4?
More things.
More formulas. But wait, even though you see more formulas, question, what do you see below the formulas?
What's the
You can use them.
That's great.
catch?
What words?
Those ones.
You can use, oh, these can be used. I totally was going in the wrong direction. These can be used, sorry, I wasn't listening. These can be used like trig identities to, wait, evaluate, what does that mean?
See what they are.
Plug in, right? Simplify. Simplify, isn't that just like using the identities to change them around? Verify, what's that? T-proofs. Or solve equations. Oh my goodness. Hold on, do these things ring a bell, guys?
No.
Evaluate, plugging in, we've been doing that for, I don't know, quite a while now. Simplify, that was like all the directions from section 5.1, pretty much. Verify, those were all the directions from section 5.2, pretty much. And then solve equations, what section did we just do, guys? Yeah, 5.3, and what was the title of the 5.3? Solving equations. So, what's the only new thing in 5.4? Yeah. Because this was 5.1, This was 5.1. This was 5.2. This was 5.3. We're not developing any new skills in 5.4. We're just looking at new formulas. So one more time, we're not developing any new skills. We're just learning how to work with new formulas. How is that good, first of all? Yeah, you don't have to worry about any new directions. There are no new directions for the most part in the rest of chapter 5. So why is this kind of bad?
Because more memorizes.
More memorizing. Okay, yeah, that's true. But what else? What else is bad about no new directions?
Makes your life harder.
That's her question.
Why?
Oh, why?
But why? Yeah.
Because we have to like look through a list of things to do instead of having a small list. We have a larger list.
That's true. You have to look at 5.1, 5.2, and 5.3. And if 5.1 or 5.2 or 5.3 didn't go well,
Then you're dead.
no, you're not dead.
Precisely.
But you need to get it better, right? We need to get better at 5.1, 5.2, 5.3 so that we can better do the rest of chapter 5. Now, why is that ultimately, though, hopefully a good thing if you use it right? Gives you more options, maybe. No. This is more like your Aflac reading business. Isn't there an Aflac one that was open book and you guys had to actually think about it though?
We don't like thinking.
Oh, yeah, I know.
We do, but we give up after 3 minutes.
Okay, let's don't.
Give up after 3 minutes.
That is true.
It's just because we're all ready, we can't multitask.
I totally forgot the question. I genuinely forgot the question.
Ultimately, it's good because there's nothing new besides formula. It's bad because you have to better understand what we've been doing. But that's good because don't you want to better understand before the test? So, it's good and bad and good. Bookend it with good. A little bit of bad in between. 5.4, I'm planning 2 days. 5.5, I think another 2 days. It's on the class calendar. Does anybody know when the test is? It's next week sometime. Remember there's a test part 1 and a test part 2.
Tomorrow is next week.
I have my calendar.
We'll switch it back to the
I haven't played that in ages. It's just chilling. You guys are way too excited. Oh, it's cool. Yeah. Non-productive. You can be powered by bubbles. How fun is that? Okay, so
She's got a point.
It's fun.
continue 5.5. Start 5.4.
Disneyland.
Wait, that's off. That's off.
You
Oh, sorry, these are mixed up. That was supposed to be on that day, and that was supposed to be on that day. Anyway, that's okay. The test is going to be in 2 parts next week. The problem portion, like the actual T-proof, trig equations, all that stuff, is on Wednesday. But remember, I said you're allowed, no, not even allowed. I'm printing off for you a formula page to use with that, right? So whenever you do your homework, so you have your formulas nearby. But is there another portion to the test?
Yes.
Ooh, and the other portion to the test is?
Memorization things.
Why is it Monday? You just have to find the formulas. And not even all the formulas, some of the formulas, and I'll be more specific as we get closer. Why am I putting it on Monday? Because I want us, hold on, I want you guys, wait. I want you guys to be able to focus over the weekend on just memorize, flashcards, Quizlet, I don't care, quiz, formulas, memorize. Okay. Then, what are we going to work on the second half of class?
Memorize.
We're going to be finishing the problems, and we're going to, well, basically, hopefully we'll finish that section here. But we're going to be taking homework questions on 5.5 with problems. We're going to be working a whole nother day on review on the problems, and then we're going to have a test on the problems.
And spiritual emphasis.
Yes, that's true as well.
Oh gosh.
And they're all chapel days, so it didn't really, in a sense of like, they're all short days, so we're just gonna do the best we can. Yeah, Jason?
5.4
Yes. There are new formulas in 5.4 and there are new formulas in 5.5, which is why I've been saying you need to be memorizing. What are the only formulas we've had so far? 5.1. Now what? 5.4. And then 5.5 is a doozy, but the nice thing is only half of them you have to memorize. But there are quite a few. Alright, cool kids, you got it? I'm trying to give you lots of time. Wait a minute, you have to memorize these?
Yes.
Oh my goodness gracious, there are 6, just kidding, 3. What?
Oh, that's it.
Don't they kind of come in pairs?
Yeah.
Yes.
Like these two kind of work the same? And these two kind of work the same? And these two kind of work the same? Oh, you can't, why not? Oh, I'm on. So. Okay, there you go. Question. Are there any ways of remembering?
Writing it down on your hand.
I like that idea. Let's go with that. Writing it on the back of the person that's going to use that.
Question. Why does co, with, or together help with the cosine formulas?
Getting the tattooed on the back of your head so you can paper.
Yeah, co with co and sine with sine, right? Co, with, or together. If you don't want to have a way of memorizing, then fine, fail the Formula 1. But otherwise, listen. Co, with, or together. Sine. No. There you go. You're welcome. What's another way of doing it?
Cosines are together, sines are together, and the tans are together.
Sines are the same, and sines change. What do I mean? The sum is a sum. The difference is the difference. The sign stays the same for sine. And the signs change. The sum is a difference, and the difference is a sum for cosine. Are there ways of remembering? The answer is yes. Wait a minute, what about tangent? Okay, we kind of have to memorize him. Except, isn't tangent for sine, isn't he sine over cosine? So won't it be same over change and same over change? No, same over change and same over change. Spanish quiz is not really our concern right now. Okay, so some ways of remembering, but now that you guys are just distracting each other, then forget me trying to help. Question, how do we evaluate a trig function with these new formulas? What's the one that we can plug into real fast?
A.
A.
Tan, the tangent one.
I was thinking B. Why am I thinking B?
I don't.
Plug in. What are we plugging in? Can't we go to the unit circle on B? Where's 7 pi over 6? What quadrant? Uh-huh. Where's pi over 3? What quadrant? Uh-huh. What's sine of 7 pi over 6? Negative 1/2, right? Because it's going down 1/2. What's sine of pi over 3 in the first quadrant, or sine of 60 degrees? Common denominators, -1 minus root 3 all over 2. All I had to do was go to my unit circle and plug it in. Right? What about letter A?
Multiply square root of 3, or pi, no, multiply pi over 3 times 2 over 2, and then subtract.
So 7 pi over 6 minus 2 pi over 6 is
5 pi over 6.
oh, and that's over here. Right? And sine would be the 150, you're right, 150 degrees. Why am I showing you these two examples on the same page and saying something like watch out at the top? Maybe sometimes you don't need to use the formulas, that's true.
But not just because they have the same things and it doesn't mean it's going to be the same answer.
Yeah, these two have the same angles, they have the same trig, but they're different answers. What does this tell you about sine? What does he not do? What is he not allowed to do? Does it work if he's distributed? No, these are completely not equal, right? So I cannot distribute sine. What's a better way of putting it? Well, sine isn't allowed to distribute, so I shouldn't say it that way. You can't distribute sin. You shouldn't distribute sin. There you go.
We can.
If you distribute sin, we're all in trouble. But what do you think your brains are going to try and tell you to do to make this easy? Yeah, sin. No! That's what your brains tell you half the time. You always have to say no. Okay?
Just say no.
We don't say no, there is grace, but still don't tempt the Lord. So, we're not in the business of distributing sin. Now, how do the formulas work? The formulas give us a legal way to go about doing this problem. Now, guys, did 5 pi over 6 common denominators, did that work this time?
Yes.
Yeah, we did 5 pi over 6, he was in the unit circle. But is there another way of solving that doesn't have to do with distributing sin?
I think so.
Yes, sine, not with or together. The sum or difference formula says do sine, then do cosine. Sine, sines stay the same, it's minus. Cosine, sine. Wait, how on earth did I get this whole thing? What formula? Oh, this is how you break apart a sum or difference of angles in a sine. The legal way. So wait, what can't you do again?
Distribute.
Can't distribute, but what can you plug into? And guess what this would end up equaling?
Not the same thing as the first thing.
Yeah. So why on earth did I just make everything harder and say, well, there's this long thing you can plug into?
Shows that you can do it.
What if I asked you to find the sine of 11 pi over 12? What quadrant is that in? That's a little bit less than 1 calzone, right?
Oh.
He's over here somewhere. But is he one of my unit circle special ones?
No. She's supposed to do that.
Well, so we don't know who he is, and we can only guess that he's something kind of close to 0. I wish, but even if we made him in degrees, he's still a non-unit circle. But what can we do? We can say, wait, 11 pi over 12, I think he's somebody special, and who is he now? Don't worry, the book gave this to us. We weren't supposed to just go magically realize 11 pi over 12 is 3 pi over 4 plus pi over 6. But is it true? Well, 3 pi over 4 would end up being times 3 over 3, 9 pi over 12, plus 2 pi over 12.
You forgot the one in the first 12. But we're not-
That's okay. We want our notes to be perfect, right? That's why it's our portfolio.
Yeah. Shows that you're
What did that do? Can I do this in the unit circle? No. But are these angles special? Yes. How are we going to solve? Oh, it's easy. Distribute sin.
No.
Undistribute sin. Good call. Do the formula. Sine. With or together? No, that's co. Okay. So we keep them apart. Start with the sine. Start with who you have. And you have to do the other one. What's the sine? Well, hold on. I'll keep writing. Sine of the first. What am I doing? Go get your formulas. Remember, you're allowed to use formulas on problems. Look at your formulas and just plugging and chugging. Sine of u plus v. Sine stays the same. What am I using? This guy right here. Him.
Whoa.
Him. I'm using him, right? Okay. Oops, now I'm writing all over my notes. There we go. Okay. I couldn't do 11 11 pi over 12, but question, can I do 3 pi over 4? And pi over 6? Yeah. What's sine of 3 pi over 4? He's at 45. And sine is positive. Oh, careful, not 1/2, not the pi over 6. Cosine. Yeah, square root of 3 over 2. Plus. What's cosine of 3 pi over 4? Positive or negative? Negative. Remember, second quadrant, cosine's negative when sine is positive, right? All students, sine is positive, cosine's negative. How about sine of pi over 6?
What happens?
For those of you that weren't humbled by the unit circle yesterday, what are you humbled maybe by today? Have a way. Have a way to do the unit circle, yeah? Now what? PEMDAS. Oh, so we used to go adding stuff first, right?
No.
No,
The
PEMDAS.
exact opposite of which was.
Multiply. Root 6 over 4 plus, negative, root 2 over 4.
No.
Any ideas?
We give up and say, stick it to the man.
You can't. Yeah, can we stick it to the man?
Pretty much. I didn't say it was going to be a nice answer. I just said it was an answer that we could find. Guess what? I don't know. Common denominator. Dun 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 dun.
Good job.
Was it 2 the square root of 1.5 be a way to write like 6? Or can you do 4 times 1.5? And then, I mean, it might not make it more simple.
Oh, because of 3 halves?
Or can you take out in the square root of
Yeah.
6? Could you simplify it by?
Not much, because you could do either root 2 and root 3, but you know what I mean with either of them root very well. If it was like square root of 12, it would do something fine, but 6 only has 2 and 3, which don't split. So what was impossible with the unit circle became possible because of the sum and difference formula. How about this guy? Nope, give it up. Throw the pen down.
Wait, it's a formula.
It's just a formula. Wait. Go look at your formulas. You're allowed to look at it. It's a problem. Whatever. Go look at it.
It's the bottom one, the last.
Yeah. But is it the easy side or the hard side?
Easy.
It's the long side. Well,
That makes it easy.
hold on. So what could we put as its equivalent statement on the other side?
5 pi over 6 minus pi over 6.
And it's minus. So you filled in the right one, right? It's the good because sine stays the same on top. Sine over changes on bottom. Yeah, it's the difference one. Tangent of u minus v, right? The signs match up. So, could we have done this one in the unit circle? Could. Would have been a weird fraction and a weird fraction and a weird fraction and a weird fraction and a complex like blah blah blah, right? Question. But if the two are the same, couldn't we just do this one? Oh, sweet. Well, forget the other side. Hey, 5 pi over 6 and 1 pi over 6. Is that something I can do?
Yeah, 4 pi over 6.
Who's 4 pi over 6 reduced? Is that a unit circle? Angle. Well, forget that. I'm not going to do it that way. That's just long and hard.
It's, yeah.
2 pi over 3 is this dude. He's a 60 degree. We just looked at our cheater chart, and 60 degree has a tangent of rad 3. My ones that would have done it maybe the other way, you would have done sine over cosine. But question, hold on. What are my signs in the second quadrant? So cosine is negative. Sine is positive. So what am I going to choose for all students take calculus for my tangent? Dun, 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 dun. So I use the cheater chart technically to steal my rad 3, but you could have also done tangent is sine over cosine. You would have canceled out those two little 2's. And you would have gotten rad 3 over negative 1, which is negative rad 3. So, did I have to do it the long way? Just because there are long formulas, does that mean I'm always using them to make things hard? No. Sometimes they make things easy because I can take a nasty expression and make it simple. So maybe, sometimes it takes something that's impossible and makes it possible. Sometimes it takes something that would be long and complicated and complex, literally complex fraction, and make it simpler. What else can it do? Oh, what do you plug in? It does look simple, right? But it's a little tricky even though it looks simple.
Oh, because it's the sign.
Yeah. Are these angles or are they ratios? Oh, stink. They didn't give me angles. So do I know what to plug into U and V?
No.
No. So how do I make it nice and pretty without, well wait, hold on. Co means with or together, right? Coco. What's going on with the sign? For cosine? No, not for cosine. Change, good. Oh, this is where they gave me those clues. Hold on, guys, where's 5 over 13 gonna get plugged in for? Got it. Where is cosine of V gonna get plugged in for? Oh, but who am I still missing? This is lame. They only told me half the information. This must be an impossible problem. Well, that's a bummer. I really wish I knew the sine of V and the cosine of U. Wait. Hold on. Couldn't I make a U and say 5 and 13? Sine, opposite over hypotenuse. Can't I make a U triangle and say, well, I know his opposite, I know his hypotenuse. There's a theorem that lets me solve for the adjacent. What theorem is that? Pythagorean theorem. Oh my goodness, this is actually one of those special ones. Oh, wait a minute. If I can make a triangle out of U, then can't I answer the question, what is cosine of U? What's cosine? But I wouldn't have known that if I didn't make a triangle from the information. So can I make a triangle for V2 also, additionally? Except cosine is negative now, right? So we need to make sure the cosine goes -3. But we have a positive because hypotenuse is always positive. Well, kiddos, hold on. If this is for V, yeah, opposite has to be 4. Oh, well, sweet. If I need my sine of V, then what am I going to plug in?
Plug it in, plug it in.
Yep, opposite over hypotenuse. One of the most common mistakes in this type of problem, there are 2 places people make mistakes. They don't do the triangles. They don't do the triangles. And they don't substitute correctly for sines and cosines. Meaning, kiddos, once I plug in, isn't the sine and cosine, aren't they all gone?
Yes.
And I just have fractions? Sines and cosines are gone. They got substituted out of the game. They had to leave. The fraction came in. Now it's just a game of mental math. Is that 65?
Stick it to the man.
65? Almost stick it to the man. Now we can stick it to the man. That's a month then. Now, just a couple of you are like, wait a minute, isn't sine positive in the first quadrant or the fourth quadrant? Isn't cosine negative in the second quadrant or the third quadrant? You might have gotten a little confused by that. Long story short, the directions will be explicit as to where to put the triangles. I didn't write very detailed directions in this problem to tell you what quadrant. So let's just say up to the side, there should have been something that said, hey, by the way, U is in between 0 to pi over 2. And there should have been another clue that would have told you V is in between pi over 2 to pi. So I apologize, my directions weren't very detailed. Just a couple of you were like, how did you know what quadrant to put them in? There were 2 possibilities. The directions will be specific. But what are the 2 keys? Make triangles.